Okay, we're recording. So hello, everybody. Welcome to the Jupyter community call for the month of June. We've been doing these the last few months now, and this is really just a place to come in and make announcements to the community on things that you've been working on, things maybe you will be working on moving forward, to share cool demos of something that you have maybe at your business or your university or research institute or whatever. Or if you just have fun announcements you want to share with the Jupyter ecosystem. This is a great place to do it. Nobody has to speak, but it's just a good chance to also see faces in the community and meet new people. So thank you to all who are here. Let me see here. So going through our agenda. So we start these things with a set of just short reports and celebrations. If you haven't been directed to the agenda that we have a HackMD file that we keep all of the agenda items. And so if you have something you want to add to it on this phone call, feel free to do it. If you have a demo or anything you want to share, you can go ahead and add yourself to the agenda right now. Otherwise, we'll go ahead and get started. Also, feel free to add yourself to the attendance list at the top of that agenda. I can actually add, oh, somebody added it to the chat, perfect. Yeah, so they added to the chat room the agenda. Cool, so just going through the list of short reports. I don't know if Carol is on the call. I don't see her, so I'll go ahead and do her. So the Jupyter Hub Binder team announced a new member got to join the team, Sarah. So we're just congratulating her out loud. Definitely go check out the Jupyter Hub Binder Hub team page to see more information about what that means to be a member. Oh, there's Carol. Hi, Carol. So yeah, congratulations to Sarah. It's awesome to have her on the team. She's been doing some great work for Binder and Jupyter. So yeah, go see that page. The second announcement we have is if you see, I'm in two calls here, but this team right here, this is the Jupyter Cal Poly team. These are our new interns for the summer. So we wanted to welcome them to the team. These are all Cal Poly undergraduate students ranging from 3rd to 5th year. So I guess we can do a little intro. You guys just wave. You don't have to speak. We won't put them on the spot. But Markel, Marissa, Jarek there in the corner, Isabella, and Javi right here. So welcome to our interns. They will probably speak on the next phone call, sharing the projects that they're working on. So, all right, cool. And then the, Carol, did you want to say anything about Sarah? I totally ran through her.
No, thank you for doing that. I was a little late this morning. No, I'm just happy that she's on the team and stuff. So no worries. Thank you for doing that, Zach.
Awesome. Thank you, Carol, for putting that on there too. All right, and then the last short report or announcement that we have is from Tim, also here at our team. So, do you want to unmute
I'll just
yours?
I'll just speak into yours because if not, it'll echo. Can you guys hear me okay on that end? Cool. So I'm just announcing. I don't know if it's been announced in the community call yet. I'm collaborating with a few different people in the community on rich context. And we're calling it rich context, but what it is it's a suite of tools that are surrounding collating data and collaborating in teams. So we have 5 projects involved in that. We're doing a real-time collaboration project, a commenting and annotating system that we have a demo of out right now, but it's not working with the real-time collaboration yet. So right now it's sort of servable and shareable, so you could share notebooks with comments. And then we also have a data registry. So we're sort of promoting data sets to be first-class entities within Jupyter Lab. And what that'll allow is you to register data sets that you've used in notebooks and then access them later outside of that notebook and do things like launch a visualization or launch an activity based on that. And then we have a metadata store that stores metadata on everything, like basically every activity that you can open within Jupyter software should be able to have metadata on it. So maybe you have a data set that you want to know some stuff about it, but not open the data set directly. You can browse through and look for that. And then the final project is a telemetry system that will allow people working with sensitive data to sort of populate matches between data sets without peeking at what the people are doing. So it's allowing people to working with sensitive data where you may not be allowed to have access to a data set. Those data providers can grab some information on how those data sets are being used without looking through those data sets themselves. So basically, it sort of started around sensitive data and is working outwards from there. So a lot of it has to do with like census data and things that are protected, and then scaling that out to general data sets, like maybe large sets like Kaggle could import their metadata directly into a Jupyter software environment. So pretty exciting stuff. It's still in its infancy, but we're charging ahead on that and having a lot of fun. So
awesome. I think I see a question from Anton in the. You wanna ask your question out loud, Anton?
Sure. Yeah. The comment in the annotation demo, you said it exists. Is there any link or somewhere one can follow?
yeah, so if you go to Jupyter Lab / it's a sub-project of Jupyter Lab right now, and it's called Commenting and Annotation, I believe, or it might have been changed to just Jupyter Lab Commenting. I'll link the repo for you right now.
Yeah, thanks.
Put it in the hackpad or
Okay.
HackMD. I mean,
Yeah, I'll put the links to all the repos that are open right now in there.
Eric put it in the Zoom chat too, so you can take a look at it. Thanks, Eric. All right. Does anybody else have any other short reports or announcements they want to make? I'll leave it open for 30 seconds.
Perhaps mybinder.org will get pip file support soon. I'm hoping.
Awesome. Thanks, Eric. Okay, so with that, we'll move into our main agenda. So the way we've been running these main agenda items is whoever's kind of in charge of their particular item will give us 10 minutes or so sharing whatever they would like. They can share their screen and give a demo, or just treat this as like a nice 10-minute flash talk. And then we'll open it up for questions at the end or comments. So anyone on the call, feel free to jump in at that time. Maybe save your questions until that person's done. And then, or start adding them to the agenda if you prefer, just to kind of log them. Yeah, so with that, we'll go ahead and move to our first one, which I believe is Kevin, who's going to give us a brief overview of the Enterprise Gateway project.
Hi, Zach, thanks a lot. Let me share my desktop here. All right, so you probably see the agenda.
Yep, that looks good.
Okay, great. So one of the corners of the Jupyter ecosystem is kernel gateway and enterprise gateway. And so I thought I'd give a brief overview of enterprise gateway, but we really can't talk about enterprise gateway without talking about kernel gateway first. And so it's probably been 4 or 5 years when kernel gateway was first developed. And the idea behind kernel gateway is that it disassociates the notebook processing from the kernel processing. So what this gives you is the ability to separate your data scientists or your analysts from where their kernels are running. So it essentially moves the kernel closer to a compute cluster, if you will. So that's what kernel gateway provides. Now, the way that's done is through a notebook server extension called MB2KG. And what MB2KG does is it essentially intercepts the kernel management requests for that notebook and forwards them to a kernel gateway. So the kernel specs API, the REST API, and the kernel's REST API all forward to kernel gateway. That starts a kernel on the gateway, and then a WebSocket is set up to then forward to the ZMQ ports and the kernel. So to set up MB2KG, it's a server extension. So you've got to pip install MB2KG. You've got to enable the server extension, and then you've got to start your notebook with, a set of class overrides essentially, along with a URL. And so one of the things I wanted to mention today was in Notebook 6.0, which is in the process of getting built or released right now, we've embedded MB2KG into the notebook server. And so none of this stuff is necessary other than when you start your notebook server, you give it a -- gateway URL parameter of where you want to route your kernel management operations to occur. And that would be routed to a gateway server. Now, a gateway server can be either a kernel gateway or enterprise gateway. And so Jupyter Enterprise Gateway is built directly on kernel gateway. But one of the limitations of kernel gateway and Jupyter in general is that all of your kernels run local to the server. And so when you, especially in a kernel gateway environment where you have a number of analysts running notebooks and all hitting the same kernel gateway server, all of their kernels will be running on that local server, and so they're not able to utilize the full cluster compute capabilities. So what we did with Enterprise Gateway was we introduced the notion of remote kernels, essentially. And so with Enterprise Gateway, we can distribute the kernel processing across your compute cluster and increase the scalability of the resource utilization of your compute cluster quite a bit. And so it ends up being a big win for larger installations that do high intense kernel operations. On our docs, we have a system architecture overview. And I just want to kind of go through this real quick. But what we've essentially done is we've abstracted the kernel process management that's done by the framework. And that's basically just a p-open response, a sub-process, if you will. And so by implementing these 4 or 5 methods, we've allowed to use what we call a process proxy from the framework, which essentially implements each of these methods. And so our kernel specs are quite a little bit more involved than what your typical kernel spec would look like. But we've extended the metadata section to include a class name, which is the process proxy class. And so users can bring their own process proxies and implement their own remote capabilities. But we provide process proxies for Kubernetes, Hadoop Yarn clusters. This distributed process proxy is essentially an SSH means of remoting your kernel. We don't pass a connection file. Instead, we convey the kernel ID to a launcher, and then we also provide a response address. So when you launch a kernel with Enterprise Gateway, we're saying, hey, this kernel is going to land somewhere on your compute cluster. We don't even know where, but you're going to send us back your connection information back to Enterprise Gateway in this response address. And then we're going to hook up your 5 ZMQ ports to that remote kernel after you've responded back to us. So anyway, so all this information here's all the different process proxies we've implemented: Kubernetes, Docker Swarm, regular Docker. There's also an IBM Conductor product that we've, this was a great proof of concept for bringing your own process proxy. This was contributed by an outside, people outside of the repo and stuff. Anyway, and then here's the class hierarchy for process proxies. Anyway, enough of that. So what I wanted to show you was our Kubernetes implementation today. And so if you see my screen, we've got I'm showing a number of namespaces that are in the Kubernetes cluster. I've got a 3-node cluster here. And Enterprise Gateway runs by default in its own namespace named Enterprise Gateway. And then here's a user's namespace that called Alice that we have this idea of you can bring your own namespace. But what I wanted to show was the default mode, which is using Notebook here. And so this user is Bob. And Bob's going to go launch a Kubernetes Python kernel. And so when this is launched, it's hitting Enterprise Gateway. Enterprise Gateway is basically creating a pod YAML file and then deploying that in the cluster. Now by default, we create a namespace for each kernel that's launched if they don't bring their own namespace. So you can see here, we've just created this for the user and kernel ID, this namespace for Bob. We tag it with various labels. It's a component is a kernel. The application is Enterprise Gateway. The kernel ID is blah. And if we go to that namespace, we see the kernel pod running. And so here's the kernel, and you can go get its logs. There isn't really much in a kernel log to look at, but that's what the kernel log looks like. And so we can do basic operations. Interrupts are done through a message-based interrupt, but they work just like sending signals. And we can run NumPy stuff. I always notice this takes a couple to get the render of the chart. But anyway, so there's user Bob's kernel. Now, if we were to start up another kernel on behalf of Bob, let's start up an R kernel. And if we go back to the namespaces inside of Kubernetes, we see a second namespace for user Bob, and that's for the R kernel. Now, I mentioned earlier we have the idea of bring your own namespace, and so this Jupyter Lab instance is emulating a user named Alice who has brought her own namespace to the party here. And so if we start up a Python kernel. That's boring. But anyway, this will start up a Python kernel. But let me also, while we're here, start up a I'm in the wrong one. Let me start up a Spark kernel here. All right, so this is going to be a Spark kernel. Spark takes a little bit longer to start up, but if we look at our namespaces, we're not going to see a new namespace. Now, one went away because we got out of that kernel for Bob, but if we go to Alice and we bring up Alice's namespace here and go to her pods, we'll see 4 pods running. This pod is that first kernel that we brought up, but it's all in the same namespace. And then these 3 pods are for Spark. By default, Spark starts a driver pod and then 2 executor pods, but the number of executors can vary depending on what your job and parameters are. But, and then, so this looks like the startup of this hasn't quite finished. That's not good. But if we do this, we can, print. We can do basic Python stuff, whatever. I can't even type here, but anyway. And if I get out of this kernel, then that should go away. Well, so let's see, did this exit? Oh, it looks like the Spark stuff had problems here in this one. All right, this is not going well. But anyway, you get the idea that, I'll have to look at that. So it looks like Spark didn't start up properly today. But all right, well, I'm not gonna worry about that. And this got in there. All right, well, I'm gonna stop the demo right now. Let's see, what else do I want to show? Oh, we have a bunch of images. So we've extended the notebook images we use as our kernel images. So we essentially, all of our kernel images also have notebook running in them, but we wanted to leverage all the libraries that the Docker stacks and Peter and all those folks that manage that have done. And so we've tried to build all of our images on the Docker stacks notebook images. So if you go up to, go up to our Docker Hub area, you can see all of our different kernel images that we also provide. Right now, the languages we provide are Scala, R, and Python, and we have Spark versions for each of those as well. We also have a TensorFlow image for Python that is that is built on the Jupyter TensorFlow notebook image. So we just had our second release candidate for 2.0. 2.0 is focused on Kubernetes. We've had great contributions from the community. The Kubernetes stuff is really exciting, although the demo didn't show that very well today. But so we're pretty excited about the Kubernetes stuff. Our 1.0 release was focused on Hadoop Yarn. That was our first prototype for this stuff, and we got that all working fine. And then we decided to use a second major release for Kubernetes. Anyway, I don't really want to talk about future stuff right now, but some of this will be available through Notebook when we go to Jupyter Server at some point. And so we should have remote kernel capabilities without having to bring Enterprise Gateway into the picture at that point. But anyway, with that, I'd like to stop and see if there are any questions.
Good stuff, Kevin. Great to see a project moving forward. If we wanted to share this information with folks, where would you recommend, what resources would you recommend beyond the documentation? Are there any talks or anything?
That's a good question. I know Luciano Hacende has given presentations at various conferences.
Okay.
And so that kind of stuff is out there. I don't know if I have a page of links to that thing, but I know you mentioned having a GIF that kind of demoed this stuff, and we've tried to do that in the time space that a GIF would allow, and it's really tough. But
no, I like it with the little kaboom or whatever, the boom. That was cute.
Yeah, so your server has just died there. It ran out of resources.
Okay. Something maybe to stick in an issue for the documentation would be, some links to some of his talks might be helpful for folks too.
That's a great idea. Yeah.
Good stuff. Thank you.
You're welcome. Thank you.
Thank you, Kevin. That was awesome. Any more questions for Kevin?
I have one or two, actually. This is really interesting. So I would like to understand better the relation between, say, a custom Jupyter Hub installation that is also Kubernetes aware and the kernel gateway. In which circumstances would say an administrator of a Jupyter Hub would prefer to also include a kernel gateway?
Right.
Enterprise one.
Yeah, that's a great question. It doesn't make much sense to use kernel gateway in that, but enterprise gateway would be something to recommend in the following circumstance. I mean, you solve a lot of the resource utilization issues just by going to Kubernetes alone. So now your notebook is now launched as its own pod in the hub world. But should the scientists need multiple kernels running from that one notebook instance, all of those kernel drivers are still local to that notebook instance. And so with Enterprise Gateway, what where we're heading with all this is parameterized kernels, first of all. But that's something that, and we do some form of parameterization already through environment variables. But what's nice about Enterprise Gateway is that each kernel pod can be its resource, its resource holder. And so you can have, you can say, I want to launch one kernel with 4 GPUs and another kernel with, this many gigabytes of memory. And you're not having to size your notebook pod accordingly to what the maximum usage is going to be. It gives you a finer grained breakdown of how you want to utilize your resources to the kernel level.
Yep, thanks, got it. So that's clear. So there was another question that I was wondering about, this extended kernel spec metadata. Does it then get stored in the notebook metadata as well?
I don't know the front end how that stuff works, but I'm assuming well, I don't know, is argv stored in the kernel metadata in the notebook? I'd be surprised that it is, but I don't know.
So usually things like minor language or minor language version are stored there. So, and the reason why I'm asked, sorry, please.
We are not storing anything on the notebook metadata at the moment.
Perfect.
So it's not automatically stored. The metadata section isn't automatically stored in notebook. I think that was the question.
Yeah. All right. Thanks.
What we want to extend on the metadata, though, and this might be getting ahead of the stuff, but back to parameterized kernels, is what I could see us doing is passing the metadata of what the parameters are, min, max value, default value, whatever, in that metadata section, and then the front end can then present a dialogue based on the metadata that's passed back for each of the parameters that you want to launch your kernel with, and then the payload, the JSON body of the start request would include the parameters, and then the kernel provider, if you will, kernel manager or whatever you want to call it, would know what parameter it, would then be able to use those parameters accordingly, whether it be passing it to the kernel directly, or really a lot of the parameters will be in setting up the kernel's environment that it's going to run within.
Yeah. The reason why I was asking about the metadata was the portability issue, because if the notebook contains too much specific information about how it would be run, then it might as well fail when given to somebody else. So this was.
I understand that. Yeah.
All right. Yeah. Thanks.
You're welcome.
Is there a document that outlines this kind of roadmap that you were describing?
You mean parameterized kernels, that kind of stuff? The Jupyter server is where we're going to be heading with this, right? The split.
I think so. We used to have a roadmap kind of like page with the directions that we want to go. I think some of the things that Kevin is mentioning, I think these are all recent discussions that we had on the past maybe 3 to 4 weeks. We are still trying to get all the documentation and that available. I'm hoping we'll get that very soon.
Awesome. Well, it's exciting to hear about. So.
Yeah, and relative to the enterprise gateway roadmaps, Luciano's right. We do have a roadmap entry on our docs. Things like high availability, having more than one server that's running enterprise gateway, and failing over. That's stuff that we are in the process of implementing and that kind of thing. It's a little bit easier to do when your kernel, your kernels are remote from your failed server. If a kernel is local to your failed server, they're failed as well. So anyway, so we were able to do some of that stuff with Enterprise Gateway. as well in remote kernels.
I got one more question for you, Kevin.
Yeah.
How do you deal with the issue of like remote kernels with a non-remote file system? Like, what if the kernel wants to call back to a CSV file?
Right. So, well, we do that through mounting or HDFS, that kind of thing. So you do need some kind of remote file system or that kind of object storage in place. I guess the same issue happens with Notebook in Kubernetes. So the idea would be that we would want to share those same persistent volumes, or convey the need. That's also one of the nice things about. Well, never mind. So yeah, we need to convey the persistent volume storage on each kernel request. We have so when we launch, we actually use a Jinja template for our kernel pod. And with that, and that was another contribution from outside folks, with that, we can be dynamic as to how many sections of the kernel pod you're going to need to create. So how many mount points you might have. It's conveying what the substitutions are. That's the tricky part, of course. But
I would like to add to that. I think that is completely true when we're talking maybe like about a small CSV or something like that. Usually, some of the scenarios we really see when we talking more about like big data and large data sets is that those might be, for example, like on a data lake or something that is shared around the cluster that you are running your kernel there. So that's one of the benefits of like running the kernel remotely. You run where you're doing the processing and where maybe it's more has more affinity with where the data is. And those large data sets then are accessible via like if you're doing analytics, maybe you have an HDFS, or if you're doing kind of like in the cloud Kubernetes, you might have object storage attached, and then those are available very close to where the processing is happening. So that's another scenario that we have been seeing a lot, particularly on large enterprises.
Thank you, guys. All right, so we'll go ahead and move to the next agenda item. Thank you, Kevin, for that presentation. That was wonderful.
Welcome. Thank you.
So I think next on our agenda is Denton.
Yes.
All right, awesome.
So this is more of a question of if something already exists that I could use. I'm working on a Jupyter Lab notebook where, as part of people working with the system, they can write out changes to local files, CSV files, JSON files, and so on. We need a path to let people submit those, that their changes can be reviewed and possibly merged into the main system. If the person working with the notebook is familiar with Git, they're familiar with that kind of development workflow, they can do a commit, they know what a push is, they know what a merge request is, then great. But I think probably less than half of the people I'd expect to be using the system are going to be all that familiar with it. And so I started working on a lab extension and server extension to provide a way, just a submit button, and either push it to a branch on the main repository or format patch and upload it to something where we can turn it into a commit. But this seems like something that may already exist. The thing I keep thinking about is if you're using notebooks to distribute homework, this seems like you're submitting an assignment. I spoke to someone at Berkeley about their systems. The way that they get homework back from students tied into systems that already existed at Berkeley. They're about managing of the class and getting assignments back, and they're pretty specific both to Berkeley and to managing a classroom. But has anyone familiar with something that I might be able to use?
Yeah, so Well, so there is a solution in the classroom that exists, but it's not fully capturing what you want. It's called Ambigrator.
I've seen that, yes.
Yeah, so that's fine for distributing, to have like a central person, a teacher, distribute notebooks, and then all the students can fetch those, they can make changes, and then they can submit them back. The problem is that it doesn't do anything in terms of, all that is like distributing notebooks and versioning them.
Yeah.
But there's no, you can't aggregate that. I mean, that would be a lot of manual work. And it's not, I think, yeah, it's really meant for distributing assignments and grading assignments more than anything. The project that we have in mind that I think sounds like it would suit your needs is a project called HubShare. So that's in the context of Jupyter Hub. HubShare's design was essentially that you could distribute notebooks, you could bring them back, and they're versioned. And if someone fetches a notebook from the source, makes changes, it's linked to that original source, so it knows where it came from. And then when you back up, it versions it and knows it can diff those two really easily. The problem is that HubShare, we haven't actually developed it. There's specification and there's a design plan, and you're totally right. We've been thinking about this. Like, HubShare has been an idea that's been around for a few years now. It's just been really, we just haven't had the resources and the people to attack it, and I think it's been lower on the priority list right now. But so we don't really have a roadmap, I guess, for it. But it's definitely a design that we've been exploring, and actually, you know, if it's something that you're interested in being involved in the development process, or even just the design process, like, it's not a dead repo, I guess I would say. It's a live repo. It just needs some love. It needs some attention.
Okay. Is it public?
It is public, yeah.
So if I search for HubShare, I'm likely to find it.
Exactly, yeah. It's under the Jupyter Hub org, I believe.
Okay.
And it is in the context of Jupyter Hub. So
sure.
I don't know how you're...
But I've set up the littlest Jupyter Hub, which went very well and works really well for this audience. So that certainly would work.
Yeah. So I, to warn you, it doesn't work. HubShare doesn't work. It really is just more of some documentation we've put as like a forward-looking plan. Carol, do you have?
Yeah. Well, I just have a separate suggestion, because Denton, a lot of folks are using it in different ways and things move pretty fast. It would be worth your while probably to post something on the education mailing list for Jupyter, because somebody may have some local solutions that we just don't know about. And they might meet your needs. So I would go ahead and ask, and it'll help everybody as well. So so thanks.
So again, searching for education mailing list in Jupyter, I'm likely to find it.
Yeah, if you go to the main website, maybe somebody can drop the link in. There's a mailing list, communications, a list, but it's a Google group that's Jupyter Education.
I think I'll find it then. Okay.
Yeah, but if you have any issues, let us know.
Okay.
Okay, cool. Thanks.
So I would also like to add that if you are about to do Git commits and from multiple sources and merge them together, doing that with notebooks is a big challenge. But there is this tool that strips the output and makes sure that all the commits that are made without the cell execution count and these
and the UID and so on.
Yeah. So stripping those out, a tool called NB strip out, or high performant version by Fast AI. Yep. Okay.
I think I've seen that in my particular case. The data is in separate files, CSV and JSON mostly. So I'm not expecting that to be a pain point, but yes.
Mm-hmm.
So can I mention also, Gigantum is pretty much doing exactly what you described already. We already used it in a computer science course at Hopkins. And basically, we have a slightly different permissions model.
Okay.
So the people with write access do not have access to master. That's like admin access. So by default, people with write access can create a branch, do their work, and then push it back. But then Git is entirely automated. So whenever a cell is executed, in Jupyter or RStudio, basically there's a sweep of the project file tree, and every new file is committed. The code that was executed at that point in time is noted in Git. So it's all sort of automated. So, you know, students can still sort of see and understand the conceptual versioning that's going on, but they don't have to like do it. They just have to do their work inside of Gigantum, and then once they shut down their session, they can just click sync, and their branch would then be available to merge by someone who has admin rights. And I mean, I'd be happy to get into more detail if that's helpful.
Okay. The same question as the last few. Is that public? Am I likely to find it by searching Gigantum and Hopkins?
Yeah, I mean, so we're a company founded by some Hopkins faculty mostly. But if you go to gigantum.com, that's our website.
Okay. Okay, well, thank you.
Thank you, Denny. That was a great question. I actually added to the, or I'm working on adding to the HackMD links to both the education mailing list and then Gigantum as well. So thank you, everybody, for your comments on that. Eric, thank you too. And Carol. Cool. All right. With that, I think that concludes our meeting for today. So thank you, everybody who came to this phone call. And this will happen again next month, July. We do these on the last Tuesday of the month. So I'll post a new announcement and tweet and everything for this. But we hope to see you again next month. So I'll stop the recording now, and feel free to hang out on this channel. It's open. So if anybody wants to chat offline, feel free to do that. So I'll see you all next month.